Hello, we're going to start with our test tubes and my makeshift uh, test tube stand. So we have 6 test tubes as you can see. And now we're starting by our first specimen. We have milk, agar-agar, or also known as gelatin. Next is vegetable oil. Our Hollandaise mayonnaise, still mayonnaise. And next is our soil. And of course, last but not the least, our water. Okay. So starting to our first test tube, we're going to extract some water from the specimen cup to put it inside the test tube. So we're going to use a syringe just to ensure there is no spill. And as you can see, I'm not used to using syringe, so there might be a little bit of struggle in order to get a proper 5 ml of water. So using a 5 ml syringe, we're going to extract water from the specimen cup onto the test tube. Okay. Setting it aside, we're going to get another specimen, which is milk. So to ensure also there is no spillage and to get a specific 5 drops of milk, we're also going to use a syringe. So extracting the milk from the specimen cup onto the syringe and taking off the needle to get an uh, accurate drop type. So 5 drops, 1, 2, 3, 4, 5. Okay, this is exactly 5 drops. Okay, so kartehan lang iba. And of course, adjusting the light a little. Okay, setting the milk aside, we're going to use Hollandaise mayonnaise. So actually, there's a bit of struggle here because Hollandaise has pepper and other ingredients on it, so it's not exactly clear. And unlike the original type of mayonnaise, this one is a little bit thicker than most of the mayonnaise. So using a chopstick as a um, tool to push back the mayonnaise onto the bottom of the test tube. So we're gonna flip the test tube stand so we can access the next test tube easier. So adding a little bit of mayonnaise here because I think because of the Hollandaise is too thick, it's actually so hard to get it at the bottom. Moving forward, then next specimen is of course our vegetable oil. So taking off the seraphine, also using another 5 ml syringe to avoid spillage. And of course, this is oil, so it's uh, a little bit harder to get this specimen. It's also a little bit hard to clean the surface when oil spills. So getting exactly a 1 ml of vegetable oil onto the test tube. So that is test tube number 4. And next is our soil. So that soil is clay soil. So it's a little looking like a coffee. So a little struggle to put the soil in since I don't exactly have a funnel that time. And we also managed to clean the surface a little bit because we spilled some soil, and of course this is clay soil, so using some uh, brush to making sure that there is no specimen at the tube. So this is agar-agar, also known as gelatin. It is on powder form. We're going to put this inside the test tube first, but we're also gonna add a water to actually get a gelatin type specimen. So putting it inside, making sure there is no spillage, and I actually don't know how to use it grams, especially this powder. So I'm actually using a 1 milliliter of water into the gelatin in order to get a gelatin onto the test tube and create a gelatin, of course. So as you know, we're going to put some cork. It is a makeshift cork also from our wines. Actually, carve those corks in order to match the mouth of the test tube. So setting all this aside, we're going to cover it and of course shake those specimens. This one is water and I fast forward it. I shake it for at least a minute and a half. Okay, so showing you that there is bubble inside the specimen and the water became a little bit blurry. So moving on to our next specimen, of course, we're going to put cork on top of those to ensure there is no spill going to happen. Still using our makeshift cork from the wine. The next specimen we're going to shake is agar, or also known as gelatin. We actually put water on it for it to have a gelatin type substance. So using a different cork because it's actually too big for this tube. Okay, so this is agar and we're going to shake it. Shaking it for a minute and a half, making sure that all those agar at the bottom of the flask or the test tube will be shaken. As you can see, the agar is too thick, so I think there's still a lot of uh, unmixed powder at the end of the flask. So moving on to our next specimen. So we're going to try a different type here. So I'm also using a powder type agar because at this time I am not sure if what kind of gelatin I'm going to use. If it's the first agar type which has liquid on it, or this gelatin agar powder type. So there goes our powder. And then our cork. So this is a extra test tube that I use, and then shaking it now. As you can see, powder is still powder. So there's not much of change on it physically or chemically. Moving on to our next specimen, the soil. So this is a clay type soil, putting cork on it and then shaking it as hard as I could and as fast. Shaking it for a minute and a half. Also using my finger as a stopper because I might break the specimen. So as you can see, at the bottom of the flask is the fine powder type of the soil, while at the middle of the flask, as you can see, there is a little bit of green type. So because that is because of the gravity and the force that I actually put onto the test tube. Next is our vegetable oil. So this one is clear, as you can see, because that is not shaken yet. So putting cork on it and then shaking it for 1 minute and 30 seconds. Okay, so here is our vegetable oil because it became a little blurry, and of course it has some bubbles on it, but still not much of a change. Oil is still oil, as you can see. And moving on to our next specimen, the 5 drops of milk. So at this point, I actually was struggling a little bit because 5 drops of milk is way too little to become a specimen. But still, as the expression per se, 5 drops of milk. So 5 drops of milk, as you can see, it's a little bit harder to see because the specimen is too little in terms of amount. And of course, this is since a powder type, it actually have white cast at the test tube. Okay, moving on to our next specimen. As you can see, per specimen that we use, we actually clean the cork before putting it to another test tube. So this one is hollandaise. I actually cleaned the tube a little bit, as you can see, and pushed down most of the hollandaise onto the bottom of the flask. And then shaking it for 1 minute and 30 seconds. Just to ensure that the hollandaise can be really shaken up. As you can see, doing it off camera, I was shaking it vigorously because hollandaise is really thick. As you can see, most of the ingredients of the hollandaise is at the surface of the flask, but still inside, as you can see, the hollandaise is way too thick. It's already at the bottom of the flask. It won't budge. Actually, shaking it vigorously or lightly does not make any difference. Moving on to our next part, we're using laser. So as you can see, this is a green laser. It is used for buildings. So it is stitched on my gloves now. The first specimen we're going to use and see the effect of the laser is agar-agar. Okay, the next part of our experiment is laser. So we're going to use a building laser. That laser is colored green, as you can see. So we're going to use the agar-agar for it. So agar-agar or gelatin is very adaptive to light, as you can see. And this specimen is actually looking like a glow in the dark. And it is a little bit blurry, as you can see. I'm actually trying to focus it a little so you can see it clearly. It also has a green looking effect from the laser. So moving on to our next specimen, we're going to have a soil. So here it is, our soil, using also the laser. Soil is not adaptive of light, nor it does not actually have reflection more than the test tube, because the test tube is clear and it is also glass. It actually bends the light or the laser a little, as you can see. This specimen actually does not have any effect on the laser. So we're using vegetable oil. Vegetable oil actually it reflects a little, but as you can see, the laser is actually not so much adaptive to it. And the vegetable oil is still clear looking, not much of a difference nor a green blurry type unlike from the agar-agar. Okay, so um, it's reactive a little but not so much from actually from the soil. Unlike the soil, the laser actually bends from the vegetable oil because oil is not really that reflective. It is glossy but not that reflective. So here it is our hollandaise mayonnaise. Hollandaise mayonnaise adapt the light of the laser as you can see on the tube. But since our mayonnaise is yellow, it does not show much of the result from the laser, more on the test tube. So we're trying to see it in the inside, but also fail to see it clearly because laser is really not so good in the eye. So I'm trying to show it. But the good thing about this is actually you can see a little green type from the laser onto the mayonnaise, so it is a little bit blurry. Okay, I'm trying to show you here how reactive the laser onto the hollandaise. Next is our drop of milk. I'm trying to see, since liquid, the milk is liquid, it is very adaptive. As you can see, I'm trying to zoom in the specimen onto the test tube. There is a bit of grain type earlier. This is from the powdered milk, and also it is very reflective onto the laser. And the specimen is looking like a glow in the dark too. This is very reflective and adopt the laser. Good. So moving on to our next specimen, we have here the agar-agar powder type. Of course, same as the soil, powder does not really adopt light or laser. It only adapts on the test tube since test tube are glass. So I'm trying to still see if there is a much difference compared to the other powder type earlier, which is the soil. As you can see, you can only clearly view the grains or the powder pieces of the agar-agar, but not so much of a difference from its state earlier. Next is our water. As you can see, the water is already blurry from because of we already shaked it earlier, and it has bubbles on it as the result of the previous activity we did with it. So using the laser, water is very adaptive also of the laser, the light of the laser, because water is clear, same as the test tube. And as you can see, the bubble and the liquid inside, which is the water, is somehow glowing. It is because of the reflection of the laser inside. As you can see through clearly the shape of the laser, how it is blending with the specimen inside. You can see that line, that is the laser. Of course, moving on to our test tubes, We're trying to see if it's all reactive or not. I'm actually going to arrange it from the most uh, light adaptive to the least one. See that I was also testing it from above the tube instead of going from the end of the tube earlier. And this is me arranging the specimens in order. So that is water. Next is agar-agar. The third one is the milk. Next is the vegetable oil. And then the hollandaise at the side. Actually trying my best here if there is any reactive from it. So actually from earlier, the hollandaise does not really react with the laser from the bottom. So I'm trying to see it from above. As you can see, there's greens on it. You can see clearly the structure inside of the hollandaise. So it is a bit clearer view on the laser type experiment. And of course, the most non-reactive of all, the soil. It does not reflect, it does not adapt light. It actually repels light. So that is our specimen, arranged from the most reactive to the least reactive one. If you can hear snoring from this side, please be advised that I am recording 12 a.m. in the morning. And also from this part, I'm gonna redo everything because of the instrument that I use as a makeshift of a Buckner funnel flask, and the paper filter is not so much good for an alternative. So let's see the latest video that I did in order for this to work. Actually this one is an iPad or eye patch, a gauze band, and a baby wipes. And from all of that, none of that actually passed for a paper filter. And also my Buckner filter is flat. As you can see, that is actually a grater, so it does not work. So I'm gonna redo all of this at this part. I'm going to redo this part for this specific part only, since I'm not satisfied with the first one I've tried. So we have here instead of a beaker, I have here my sugar bowl. It is clear, as you can see. It is not wet nor moist. So you can see the specimen here. This will be our beaker. And then we have here a funnel acting as our Buckner funnel. So I just saw this at my baking tools, or we're gonna use this as a Buckner funnel. And this is a coffee filter. It has the same porosity of a filter paper as I actually researched about this. So we're going to make this coffee filter as our paper filter, so we could actually move on from this specific task on our activity. So what I did is I opened up the paper filter, the coffee filter actually, and put it inside the acting Buckner funnel. Okay, so what I did is I put the coffee filter here at our acting Buckner funnel, and our coffee filter is the acting paper filter since it has the same porosity and it also filters. What are we going to filter? So our specimen includes the original specimen, but I actually add a little bit of amount compared to the original. I did not include the soil and the mayonnaise because the soil actually don't go through the filter. You obviously know that. And then, of course, the mayonnaise is too thick. It will not go through. It will only sit through the paper filter. So what we have here, a gelatin. So last time, I actually use a powdered gelatin or a gelatin that has only been mixed inside the test tube. While this one is a already gelatin type, which I already did earlier today. So that is a very thick. Oh, actually shake it a little bit because it will not fall out of the test tube if I didn't. So we're going to test this one first because this will be of course in a meter of the porosities or in the meter of all the things we tested earlier. This will be included from the solids. So we're going to test it now. I'm gonna do a little push. As you can see. Okay, so we actually added the gelatin from the test tube into our paper filter, acting Buckner funnel, and beaker. So this is the state of the gelatin inside. As you can see, the gelatin does not actually come through or does not really filters. So our beaker still has no specimen on it. The paper filter actually holds the specimen gelatin inside the filter. The paper filter, since it seeps through the remaining moisture and water from the coffee filter. So it actually has some, but it actually does not really come through into the Buckner funnel. So our answer is no, it does not filter. Moving on, we're going to add another coffee filter. We're going to add another coffee filter here, our makeshift Buckner funnel. And the next specimen we're gonna do is the milk. So this is not actually a milk. This is a powdered milk that has water on it. And then I just added a few amounts so we can actually see through the specimen well, unlike the original 5 drops of milk. So now we're going to pour it in our paper filter, beaker, and our acting Buckner funnel. Now we're going to add the milk. As you can see, the paper filter filters the milk and actually goes through the Buckner funnel and into the beaker. So does milk filters? Yes, it filters. We have no specimen anymore. comes through our Buckner funnel into our makeshift beaker. So, does the milk have separates on them? No. I already cleaned the Buckner funnel and beaker. So moving on, let's go use another coffee filter. Okay, now we're going to insert the coffee filter inside our Buckner funnel. And now, there's no specimen on it. Next stop we're gonna use is the vegetable oil. So I also already shaken it for a few minutes. That's why the state of our oil is a little bit blurry because it already has bubbles on it and the bubbles already evaporated. And actually moist a little, as you can see. And still we're gonna shake it a little for you to see. Okay, I shake it again. This is the original state of our vegetable oil. And then moving on to our Buckner filter and paper filter. We're going to pour it now. Since this is a oil, we're going to see if oil passed through our paper filter, and gonna wait for a few minutes. So you can see the paper filter has still most of the oil. You can see droplets. So we're gonna wait a little while for it to filter. So it takes 5 seconds for it to filter out. So does vegetable oil filters? Yes, it does. As you can see, there's oil inside the beaker, and the beaker still has some oil in it. Yes, it does filter. But it takes a really long time before it actually filters through, since vegetable oil is a little thicker than water. Okay, moving on. Okay, so already cleaned the beaker, the funnel and the beaker. It does not have any specimen on it. Then now, next to our last specimen, water. As you can see, already put the paper filter. And then our last specimen, the 5 ml water. So you're gonna shake it a little. So the already shaken filter water, as you can see, it has bubbles on it. And now onto our paper filter. I'm gonna show you in the best view of it. Since this is water, it really filters out easily. As you can see, most of our specimen is inside the beaker now. And does water filters? Yes. That is, does it have any specimen left on it? It does not separate, so it's still a pure compound or pure substance. As you can see, this is the water inside our beaker. So does water filter? Yes.